Let's use this video to make or to run through a couple examples of the distance formula. Distance formula. And it is C equals the square root of, let's see, D. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And you need to watch the previous video on the introduction to the distance formula to make sure you understand, if you want to understand where this comes from. Simple application of the Pythagorean theorem. So let's look at a couple. Okay. Here's our plane. I'm going to put an arrow on that thing. That'll work. Let's see here. Okay. So that's the origin. Let's find the distance between the point over 1 up to. There's 1, 2. So this is to make sure that you can see. I take marks. Okay, 1, 2, and let's go over 1, 2, 3, 4 down, or let's go 4, 1. Then we'll bring in negative numbers next time. So this is 1, 2, and 4, 1. Okay, and what we want to do is find that distance. So we get that the distance formula d equals, so the difference in my x coordinates, that's going to be the difference in my first two coordinates. So x2, 4 minus 1 squared plus y2. So again, so here was my x coordinates, x and x, my first coordinates. Then my y coordinates here are the second coordinates. That's going to be 1 minus 2. And we get that the distance equals square root of 4 minus 1 is 3 squared plus 1 minus 2 is going to be a negative 1 squared. And we get that our distance is going to be the square root of 3 squared is going to be 9. A negative 1 times a negative 1 is going to be a positive 1. A negative times a negative is a positive. 1 times 1 is 1. So our distance equals square root of 10. And that's going to approximately be about 3.162. Okay? Let's do a second one. Let's switch colors. And let's say we're going to go from negative 1, 3 there to 1, 2, 3, 4, negative 1. So it's going to be a negative 1, 3. Hold on. Negative 1, 3 to 4, negative 1. And what we're looking for is that distance there, the distance to those 2 points. Okay, and applying our distance formula, we get that d equals the square root of the difference in their x coordinates, or their first coordinates. So it's going to be 4 minus a negative 1. Squared plus the difference in their y coordinates, and then negative 1 minus 3 squared. And we'll get that my distance equals the square root of 4 minus a negative 1. So minus a negative is a plus, so that's going to be 4 plus 1, plus, and a negative 1 minus 3 is going to be a negative 4 squared. So we get that d equals the square root of 4 plus 1 is 5 squared plus negative 4 squared is going to be a positive 16. D equals square root of 5 squared is 25 plus 16. So D equals the square root of, it's 25 plus 16. No calculators. Let's go. 5 plus 6 is 11. Carry the 1, 2, 3, 4. 40, 41. Okay? Clear? 25 plus 16. 41. Take the square root. We get 6.403. That's about 6.403. Okay, and so when just using this formula, you just have to make sure that you use your first coordinates with the change in your first coordinates or your x coordinates, and then the change in your y coordinates. And it actually, because you're squaring, it's going to make everything positive. It actually doesn't matter what order you do it in. So that's going to conclude these examples of the use of the distance formula in the coordinate plane.